In this video, we will solve a classic thermodynamics problem about work done by an ideal gas during expansion. We are given 1 mole of an ideal gas. The initial pressure is 1 megapascal, and the initial temperature is 27 degrees Celsius. The gas expands until its volume is doubled. We will compute the work done in 2 cases: isobaric, meaning constant pressure, and isothermal, meaning constant temperature. Let's write down the given data and unit conversions. First, let's build an intuition with a simple cylinder and piston. As the gas expands, the piston moves up. Work done by the gas on the surroundings is the force times distance, which on a pressure-volume diagram becomes the area under the pressure curve from the initial volume to the final volume. Now, let's draw the pressure-volume diagram. We'll place pressure on the vertical axis and volume on the horizontal axis. We mark the initial state at volume V1 and pressure 1 megapascal, and the final state at volume 2V1. Case 1, isobaric expansion. Pressure stays constant at 1 megapascal while the volume doubles. On a pressure-volume diagram, this is a horizontal line from V1 to 2V1. The work is the area under this line, which is a rectangle of height P1 and width delta V. For isobaric expansion, work equals pressure times change in volume. So W equals P times V2 minus V1. Because the final volume is double the initial, delta V equals V1. Using the ideal gas law, initial volume equals nRT divided by P. Let's compute. V1 equals 1 times 8.314 times 300 divided by 1 million, which is approximately 0.0025 cubic meters. So W equals P times V1, which is about 2,494 joules, or 2.49 kilojoules. Now, case 2, isothermal expansion. Temperature remains constant at 300 Kelvin. For an ideal gas, pressure times volume is constant when temperature is constant. So the curve is a rectangular hyperbola. At double the volume, the pressure drops to half. So from 1 megapascal down to 0.5 megapascal. The work is the area under this curve from V1 to 2V1, which equals nRT times the natural log of 2. For isothermal expansion of an ideal gas, work equals nRT times the natural log of V2 over V1. Because the volume doubles, the ratio is 2. Now substitute the numbers. 1 times 8.314 times 300 times natural log of 2. That gives approximately 1729 joules, or 1.73 kilojoules. To summarize, when the volume doubles from V1 to 2V1 for isobaric expansion, the work is about 2.49 kilojoules. For isothermal expansion at 300 Kelvin, the work is about 1.73 kilojoules. The isothermal work is smaller here because the pressure drops during the expansion, so the area under the curve is less than the constant pressure rectangle.